So that
Maybe
one, oh, the quality. Sorry.
it's okay. Yeah, it has to do with compression too. I don't know. Sometimes it compresses, things.
So I
That's
can
a
read it to you if you just want. It's a 4 and then radical 3x, then 5 radical x minus 2 radical 3, and then
okay.
in parentheses.
Shall we do this one right away? Is it okay?
Sure.
All right. Now, you don't have to convert into exponential form like a fractional form. I don't recommend you do that.
Right.
Sometimes they do that. So here's you have to distribute whatever's in front. You can think this as a GCF if you want. But yeah,
Okay.
this is distributive property. So you can do mental math or you can write them all out. Have a look at what I would do. If I write it all out, it would look like this. 4 and the 5 I kind of put them together because you have to multiply that. And then the roots, it looks like this. Inside one root. And then minus, and then the 4 and the 2, and then the root of all that. I'll put the first root and then the 3. There. This is how you can organize it if you want to be safe. Now, some student would do this mentally without having to actually write out the expansion like this at all. So it's really up to you. So here's why. Let me see. Now, this is one way of doing it, but let me see if you don't write this. Have a look, okay? So if you were to focus here and then multiply it in, 4 times 5 will be 20. So you write that right away. Now, this part, a root 3x times a root x. Root 3x times the root x. The root 3x has 2 roots. If you imagine they're broken up into 2 roots, a root 3 and a root x, and next to each other.
Mm-hmm.
That means a root x times a root x is what you're technically doing. So what is root x times root x? Do you remember? Like a root x times a root x.
Is that like root x squared?
And what is root x squared? There's two
X.
x. Yeah, there's 2 x's. Now, some student already know this particular. Anytime you multiply a root of the exact same inside, like whatever's inside, the inside comes out once. That's it. If you didn't know, like you see the x, root x times root x, if it's root 5 times root 5, 5 will be the answer. Root 6 times root 6, 6 will be the answer because it's like 36 and x squared will be x squared. You know how you bring out once. So there. But you see the root 3, there's nothing you can do. So keep it in there. Now you can also look at this if you want to use the one that I've written here. I recommend you don't because you can do it mentally. It will be much faster. But let's try it. Let's continue. Try to imagine ignoring that. Okay, now 4 times 2, a minus. 4 times 2, 8. So we're doing this and this.
Yep.
Then this time, a root 3 x has root 3 times root x. Imagine you split them. Therefore, you have a root 3 times a root 3. So root 3 times root 3, that'll be just 3.
Okay.
Is that okay? And then, but there's a root x that is left.
Okay.
Therefore, root x must be kept. Now, if you cannot do this, sometimes that's why I've written it here. You may have to expand it and then look at it. Now, okay, now let's pretend you did it this way. Let's look at it. Here's your 20. And here, remember, there are 2 x. Anything repeats, you bring it outside once. Here it is. And then this root 3 is left. So just leave it in there. And here it is. This is going to be your 8. But then remember, there's 2 3s. See that? There it is. You bring it out once.
So
there it is. And then keep the root x. And that's it. And yeah, you have to clean that up. But if you look at these, you have to kind of look at it one more time. They're not like terms, so you cannot combine them to be equal to one term. So you have to keep it like split like this, a binomial, I guess. 24x. Final answer here. Now I'm gonna imagine. I think you probably want to do this, right? Right here. See this?
Yeah.
That may be the safer way. But you can. This one is made to mess you up. I can tell. You see how they have a root 3, and then inside here one is a root x and then a root 3. I can see they made this up to see if you can really handle it. This is a trick problem. I already know it. I've seen this before. Like, hey, what do you keep? What you don't keep? But they look the same. That's combined in here. So anyway, I guess you can do this. I think you can do it. expand them out, write them in the root, all in the root, the number, all the number in the front, and then multiply them later. Okay, okay.
Mm-hmm.
I think you're okay with this one, right?
That one's
For,
just like fill in the blank.
yeah, foiling it. I would not care. I would just do it the order that I know how to do it.
Yeah.
You know.
Yeah.
So I do. How is this one for you?
That one makes sense. Foiling.
You think you're okay?
Yeah.
Yes. And combine like terms. Don't forget, you're likely going to get x squared at the end.
Yeah.
So that means that's a -1 as part of it. If you're multiplying it by 7, then it'll be
Oh, okay.
-7. Right? Are you okay?
Okay.
Yeah. So be ready for that. I think this is the square one. That's what they're doing
That is
here.
squared.
Yeah, so if that's squared, that means this will be a positive right here. You see why?
Yeah.
Because this is a negative, and then there's a negative right there. So it'll be a positive there. So I recommend you do them separate. Yeah, I wouldn't fill in the blank. That looks confusing. Okay, this one looks like the one you have to make sure you know. It looks like that worksheet that my other student has.
7, and it's to the third. They're all to the third power.
Okay, good.
24 minus 81 to the
Okay,
third, and then plus 4, to the third,
okay,
375.
75. Got it. All right, here we go. Let's do this one. This is like supposedly it's basic. Yeah, let's get this one right. All right, 24. Again, if you do not know the cubic number as one of the factors,
Mm-hmm.
then you'll have to break them all up. Yeah, I actually don't know it. So just break them up. 12, break them up 2 and 6 and 2.
Then
So
2.
it's 8. I actually do know.
Take a 2 out.
Yeah, so that's it. So take the 2 out. So it'll be 7 times 2, cube root of 3. Is that okay? Yeah.
Mm-hmm.
In the textbook, it'll be written like this to show the work. It'll be 8 times 3. And that 8, you're supposed to recognize that as a 2 on the outside for a cube root. Is that okay? Yeah.
Yep.
So that's how they would show it if you don't prime factorize it. Okay, 81. It's actually not bad. So 81. You can do a 9, 9 if you want.
Yep.
But then
And
you have to
then
continue.
break
3,
3.
3, and then 3, 3. But then you only pull out 1,
Take out
3.
1 3.
Yes, so 1, 3. That means you still have to keep the leftover 3 inside the cube root of 3. It's okay so far?
Mm-hmm.
And then 375. Now, they made this so that it's easier to manage because anything that ends with 25, 75, 50, that means 25 can go into it. So I recommend you use a calculator if you're allowed to do it. So here. So,
I think so.
so let's do 25 times something. So I'll divide by 25, 375. Because if you were to break it like by 5, it's too long. You can imagine that, right? Like the tree will be really long. So let's try this. 25 would be 15. So 15 here. That means you can do a 5 and 5 here. It's not bad, by the way, but it would be longer than the tree that you see here. And then a 3 and a 5. Or 5 and a 3. It doesn't matter here. But anyway, here are your three of the repeated numbers here. So bring it out, but you have a 4. That means you have to keep it there. And then bring out the 5, which you're going to multiply to the 4, but keep the cube root of 3, the remaining leftover factor in there. There it is. Oop, I forgot my 3 here. I think because I touch it, it would undo it. Okay. So here, they're like terms, but you can clean it up a little bit before you combine them. So it's 14 root 3, cube root 3, and a 3, cube root 3, and a 20, cube root 3. So they're like terms. You have to combine them. It's like 14 minus 3 plus 20. 14 minus 3, that's 11 plus 20. So that would be 31 cube root of 3. Final answer. You can keep, you can do however you like here. Yeah, combine the coefficients and keep the
Oh,
root.
okay.
Is that okay? Yeah, keep the root behind it. It is similar to 14x minus 3x plus plus 20x. They analogize it in an example in textbook like this. Yeah, if you do this for the first time.
Would the cube root of 3 just be 1, or would that just stay like
Okay,
that?
I know this is actually something that a student think it. No, anytime you have a root, a particular root number, like I'm sorry, a particular n root, they call it, right? You have to come up with a number that times itself 3, 4 times. It depends on the root number. So
Yes.
So can you come up with a number that times itself 3 times equals
No.
3? That's why you can't. Yeah, it looks like it's. I know what. Yeah, it looks like it's simplified to a 1, but yeah, it's not. Is that okay?
Yeah.
You're thinking. What do you think is the base one is the 8? That's what you're thinking. See?
Yeah.
But okay, I see a 1. I think you're thinking 1. Okay, let me show you the 1. So I see what you. I see. I see. Okay, here's if you ever have this here, a cube root of 1. The answer is 1 because you can do it 1 times 1 times 1. That's why the answer is 1. There you go.
Mhm.
So I believe this is something that you may be thinking of, but it's not the same as this. So the answer is done here. This is final answer.
Okay.
Yeah, if you ever have a cube root or any root of 1, it will be 1. It will all automatically work by be by timing however many times the root numbers you have. Okay, so here's your final answer. Okay, let me go here. Rationalizing this. But I
Yeah.
have to make up another one because this is not. I don't think this is the test one. Oh, the quiz maybe, but the test one, I'll bring it in. I'll show it to you right
No.
now. But I'll do a one that's more likely, not this one. This one is a
Okay.
quiz one, maybe. Okay, so I think you know how to do this one. It's just you square root multiply by the square root, like that. Hey, look,
So
my palm. Undo it. Wow, I didn't touch.
8 root 2.
Yeah. So root is that okay? Do you remember why? Because
Yeah.
of the root. Yeah, because of that
Because you
root
need to
there.
cancel out the root. Okay.
Yep, exactly. So you get 8 root 2 over. Now you can mentally do this here. Remember,
3.
anytime you have, yeah, it's a 3 times 2. You can see, just keep in mind, anytime you have a root number times a same root number, it's always the number inside that comes out immediately. So root 2, that's a root 4, of course, but you don't have to think it. It's a 2. Every time I see a repeated root like this, exact same number inside, the number inside is the answer, always. So it's going to be 2 times 3, which is 6, so forth.
Okay.
Okay,
Okay.
and then reduce for your final answer. 2 can go into 8 4 times, and it's 6 3 times. There you go. You cannot go on and reduce, yeah, the 2 inside the root. They're not like terms for you to do that. Okay,
Okay.
here's what I'm thinking. If it were a test and not a quiz, this is how it would have been written. Have a look. It would be a cube root. Let's just say I'll
Oh.
do a basic one. And it will not work the same way that you did here, by the way, right here. It will not work. So let's say it's a cube root of 7. Oh, no, let's do a cube root of 2. Let's do it. Okay. I assume you're probably going to do a cube root like this, right? 2 and 2.
Mhm.
It will not work. Let me show you. Let me show you that first. But this is a test problem for sure. If
Okay.
it's, yeah, I don't know about it. I don't know about the quiz that you're going to be taking. But this is a test, just in case. What about just in case it may be on the quiz? It's possible. So if you do this, have a look at what the answer is going to turn into. It'll be 7 cube root of 2. But the bottom here, now this is not the same concept as a square root timing a square root. It's a cube root. So therefore, it'll be 5 cube root of 4. And then you cannot simplify it. You see it?
Mhm.
You don't have a number time whatever, so you can continue trying to multiply the cube root of 4. It will never actually get rid of the root in the denominator. You see what's happening here? So
Yeah.
that means you cannot do it exactly the same way you did it here or multiply it here. So this is how you do it. Supposed to do it. Let me show it to you right now. You're supposed to come up with. Okay, here it is. It'll be 2 squared. Let me see if you understand why. You have to time a cube root of 2 squared. Why? Because if you do multiply them together in the denominator, in the numerator, you don't whatever happens in the numerator, you keep. but the denominator is the key. Here's why you multiply by a cube root of 2 squared. The denominator looks like this. If you do combine them in the denominator, it'll be 2 to the third. You see?
Mm-hmm.
Now you have the 2 in the denominator. The answer comes out as a 2 on the outside. So let me finish it up here. It'll be a cube root of 4 on top. And you'll keep that exactly all the way through for your final answer, unless the 7 can be reduced or cross-cancelled with something else. But anyway, if I continue, here's your final answer. But I'll explain again. I'll recap why you're doing this. You okay? This is supposed to be 2, so it's 5 times 2. So it's 10 on the bottom.
Okay.
Do you see why? So what you're trying to do here is that if this is 2 or 5, it doesn't matter. Then you have to times it by a cube root of 5 squared, if this were 5. So that you can match, it's a 5, 5, 5. You see that? It's like a 5, 5, 5. You want the number repeat 3 times. Why? Because of the cube root number, the 3. That's it. Is that okay? If this were 12, you have to do a 12, 12, all of it like that. That's it. You basically try to match up the exponent. Let me do it quickly. One more. 3 cube root denominator, whatever on top, whatever. And this is 7 squared. I'm making this up. 49. I don't think you're gonna get it. But if this were the case, guess what you do? You do a cube root of 7 to the first power. So you match up. You
Okay.
get it. You see it? You see the pattern here? That's it. You get 3 sevens in the denominator. That is the whole idea. So there's 2 7 already. You add one more 7 to it, but make sure you multiply by the same root number. That's it. So this is a test
Fair.
problem. Yeah. For you
Okay.
rationalizing it. Yes, for sure. The quiz, you may be okay with that. All right, let's
I
continue
hope.
here. Is that okay, Carmen?
Um,
It's still something. I think your teacher hasn't gone over this yet. Then,
she
right?
hasn't. No.
Yeah, but do you see why I did that though? Like, hey, you're trying to get as many twos. You make up your own. Originally it comes out with just
Okay.
one two. So you do two more
Yeah.
twos.
Wait. I think I
You see that?
do
You
get
go
it.
two more
Yeah.
twos.
Yeah. Yeah.
There
Yeah.
it is. That's why. Then it will work.
Okay. Okay.
Then it will turn into a
Okay.
two on the one two on the bottom
Yeah.
here. That's it. That's
That
why.
makes sense.
Yes. Just in case. Just in case. It'll be like an advanced 5 points, 5 point problem on a quiz. I don't know.
No, she likes to do extra credit, like on the
Oh, oh,
quizzes. Like,
oh,
if you
okay,
get this one right, you'll get an extra blank amount of
okay.
points.
Therefore, it's a extra credit if you teach it even attempt it. But it is algebra 2. I promise. It's not honors algebra 2. It's algebra 2. So I
Okay.
believe you're gonna have to do more of it before the test. Yeah, that's gonna be introduced. I'm pretty sure. But okay, let's continue with this one. Okay.
Okay.
Again, you can think negative on the outside right away because this is odd. Is that okay? If that's odd,
Mm-hmm.
the answer will be negative. If it's negative, if it's a cube root of a negative number, it will be a negative answer. But then
Okay.
250, let's see, 250, 25 times 10, 5 and 5, 5 and 2. You okay? It's really
Yep.
it's really 20, it's really 75 times 2 if you know it, but it's okay.
Oh.
Yeah, no, don't worry. Let's do it this way. I would have done it the same here. So it'll come outside unless, yeah, let me organize it. Sorry, let me reorganize it because you have more to deal with. So let me rewrite it inside as 5 cubed times 2. Is that okay? For
Mm-hmm.
the 250. And then you'll keep the a to the 6th power. Why? Why do I do that? Well, let me see if you're okay. Why am I keeping that and not? Let me show. Okay. Let me do the b first. It'll be b 18
Don't wait. Wait.
and b2.
Don't we take the 5 out because it's
Yes,
5 to the
we
third?
will. But the reason I kept
Okay.
it in there is because you have the other ones to reorganize. Because you cannot actually get the answer by pulling out this right away. Like as an answer, you have to do something in there. Like like I did it here. See that?
Mm-hmm.
So yeah, I have to keep. I could. You can pull out the 5, but that means you have to still deal with the variables, the a, b, and c. Yeah, you could do it,
Mm-hmm.
but this is actually more common. If you don't want to you want to pull all the answers out like the thing at the same time. That's what I'm getting at. You know how you want the 5 to be pulled out, but I think you should wait for the other ones too. Get it? Like at the same
Okay.
time.
Yeah,
Okay.
yeah.
So I have a question. Here, when I organize the a, b, and c variable, why do I keep a being exactly a to the sixth, and why am I breaking up b's into the b into two b's, and then why am I keeping c as is? So that's my question.
Because 3 goes into 6 and 12
Yes,
evenly, but not
that's
20.
good, very good. And how's this for you? Are you okay? Why am I choosing 18?
Because 18 can go into 6 evenly.
That's it, and it's the biggest number. After you break it up from the 20.
Oh,
I'm
really?
sorry.
Oh,
Is that okay? Yeah. You
yeah.
should you should choose the number below 20 that is the biggest number that is divisible by 3. So it's
Okay.
18. But then you still have to keep the 2. But the way you write it, it's like this. Is it okay? For the
Mhm.
B's 20th. All right, now here it is. This is what you wanted to do. That's I think I recommend you extract all of it at the same time. So here it is, the 5 that you want, but don't forget the negative. It'd be a 5. I would cancel that. This one will be a squared. You agree? 6 divided by
Yeah.
3. And the b, what is that? 6. Is that okay? B is 6 power.
Yeah.
And then the c,
Wait, why is it to the 6th? Because
because
2.
18 is divisible by 3. Divided by 3 6 times.
Oh, okay, okay.
Is that okay? Yeah, 8, because 6, wait, yeah, 6 times 3 is 18, right? Yeah, yeah. You get that?
Yeah.
It's like
Yeah.
18 divided by 3. Yeah, 18 divided by 3. Like you said, 6 divided by 2. That's why I wrote a squared, a to the
Okay.
second power. Then c. What about c? C to
It's the
what?
4th.
Yes, that's it. So I recommend you slash out or cancel, track more. That's how I keep track by slashing through the thing to extract. Okay, now cube root. This is very important. A lot of students forget to write the cube root number. Keep it in there, and then write the remaining number that you have left inside or
Oh, cube
variable.
root.
Yeah. See, did you forget?
Yeah.
Let me warn you. On the quiz and the test, happened to me all the time when I was doing this for the first time in high school. I remember I get marked. I remember it. So the original problem is a cube root, the answer has to have a cube root, not square root. That's it.
Okay.
Yeah, that happens to everyone. So I'm making a big deal right here. I want to point out. Yeah, here it is. Big old star here. Make an emphasis here. Don't forget because of this right here. Yeah, it happens right away. All right. That means let's talk about this. Now, do you understand why you're doing adding 3 and then divide by 4? It's because you're supposed to isolate the root term. It doesn't matter what it is, square root, fourth root, cube root. So
Okay.
your objective is to isolate that completely. So that's why you add
This
3.
one we went over today, so it kind of makes more sense just because it's fresher, but I don't 100% get it yet, so I don't know.
Okay, let me go over this one and then I'll bring in another one. I'll Google it or
Okay.
I'll make it up. I can make it up. Okay, this one. So why you're doing all of this is because you're trying to get this to be by itself right here, the cube root. Is that okay?
Okay.
So you
Yep.
add 3 and then you combine it with 9. Let's say you got 12. That's correct. And then divide both sides by 4. You want to get rid of this 4, like this right here. You want to get rid of this. You want to get rid of that. So but you got to do it in the proper order. So you got to add first and then you divide. Yeah, that's it. So when you divide, you get 3. That's good. Imagine you're here. You get cube root of x plus 8 equals 3. So here it is. This step tells you for you to continue, you want to drop this base x plus 8. The only way you can do that is cube root both sides or raise to the third power. So when you do
Right.
that, right here, you should be making a note. Anytime you raise to anything power, starting right here at this step or right here on yours, you want to make a note, check. You want to write CHK right away. Because this is when the only reason why you check the answer is because of what you do at this particular step. Only right here. You don't check it until you start doing it right here. So that's algebra. Okay. Anyway, are you okay with raising it to a third power and you get this
Yes.
dropped?
Yes.
Okay, good. And then you deal with
So
3 to the third, 27. That's good. Okay.
something that we did introduce today is like doing fraction stuff with the
With the root,
radicals.
with the okay. Yeah.
Yeah. And then like I got that for the most part because it was just like x to the 1/3 is the same as the cube root of x. But
Yes.
like when the teacher did like fractions, like x to the 2/3, I was really lost with
Okay.
something.
Yeah. Let's work on that right now. So
I don't know if I sent that over, but
you
that's what I
oh
really was
let me
confused about.
let me see if you have that right here, right here. This is what you're talking about, right?
Oh, okay.
Okay, good.
Yeah.
Okay, now before I work on that, you're supposed to check this 19 back into the very original. Is that okay? I think it works,
Oh,
right?
really?
Yeah, very
Okay,
original.
I didn't do that.
Yeah, your teacher meant trying to actually point out here. I think yeah, right here on the bottom, you're supposed to check. You're supposed to check your answer here, and then the rule says that hey, when you check it, you may get like I don't know, no solution, whatever here, two solution. There it is. So plug it back in. So it will look like this. Just kind of eye it quickly if you need to. Actually, yeah, just show as much work as you can. So 19 plus 8 right here, minus 3. You question mark it. Well, that gives you 9, the very original. So it
Okay.
will because of this right here. Root set 27, 4 minus 3. Keep questioning, put a question mark there. It will give you 9. So 4 times cube root of 27, which is the same thing as 4 times 3 minus 3. So there it is. It is going to be equals to 9. You can stop right here if you want, or you want to continue one more step. It's 12 minus 3, which is 9 equals 9. That's why it's true. So then you keep it. Then you can box it, and then yes, you say check like that.
Okay.
Okay, yeah, you got to check your answers. This is only one. You may have two answers. You may be wondering, how do I get two answers coming out of it? Here it is. Let me show it to you right now. Here it is. See it? So you square both sides. Imagine you do, maybe it came from somewhere else. You square both sides. Could you see? You get quadratic right here. Equals 64. So you add this 5 over and you have two answers coming, plus and minus. Remember this one? Yeah. Plus or minus square root of 69. See that?
So you
You
subtracted.
add both sides by 5 first. So you
Okay.
get x squared equals 69. And then the answer is supposed to be plus or minus square root of 69. If you can simplify that, but you can't, it's really, what is that? 3 times 23, but you cannot break 23 up. So this is done. But the answer that you
Okay.
check is supposed to be x, a positive root of 69, and x, a negative root of 69 in the original problem. But I didn't make up the original. So whatever this is,
Whatever
plug it
that
in there
problem was.
and plug it in there. Is that okay? Yeah.
Mhm.
Check both. 9 here, not 64, but 9. Okay, now keep that in mind. Check your solutions, whatever. Plug it back in the original. Okay, here. Let's talk about these ones right here. You're supposed to apply this rule. Okay, I'll write it exactly the same. Or you can look at it if you want. The m looks like this. It's still attached to the variable. The numerator,
Okay.
the numerator of the fraction of the x of the x to the fraction, the numerator will stick with the variable, the base.
Mm-hmm.
So let me see. Let me see what your confusion is like this. Okay, let me see. You want to convert this? Yeah. So all right. I know that you got. I hope you got this. If you want to do a step at a time, it will look like this. Let me show it to you before you get to the final answer. Let me write over here. It will look like this. It'll be a x squared fifth root for this one.
Okay.
When you write this next to each other, it's implied it's multiplication. So there's a dot there, so I emphasize the dot. And the
Mm-hmm.
y will be fifth root of y to the fourth power.
Okay.
Now, yeah, let me do the last one here. Times, I'm converting this last one, a fifth root of z to the first power. Now, how do I know to do that? It's based on this rule right here on the bottom. I'll write it up here.
Okay.
So it's like this. Okay, use m and m. M, so here's the rule. X to the fraction m over n, this is my m, it's equals to xn and m, I'm sorry, that's wrong. It'll be m and n is the root number. So this is the rule. That's my m
Okay.
here. So the numerator of the fraction will
Mm-hmm.
stick with the variable, the base. The denominator will be the root number. Yeah, try. You'll get used to it,
Okay.
but I think it's kind of new to you. Now, so this is technically should be the next step, but then
Okay.
send you have the same root for every single term, like the x, y, and z. You can write them in the same root. So here's your final answer. Now, the one missing here is you don't need, remember anything raised to the first power, you don't need to write it. So that's why this is your final answer coming from here. So you teach to skip a step here, technically. Now,
Okay.
again, if you imagine it, you don't have to write the step at all. Yeah, so technically you can just write that as, you can write the answer right away.
Okay.
So,
That
but,
makes more sense. I get that. Yeah.
okay, good. Now this one, going backwards. So you're supposed to look at this and then go back this way. Look at this and go back this way.
Mm-hmm.
So, all right. But if you find it difficult, you can break them all up. I don't normally do this. I don't even do this myself. I normally would jump to the answer, but I think for learning reason, you may have to imagine or break it up or write it here. I think I may recommend you to do it this way. I'll break it up into different roots, but still the same fourth root though, because you're coming from the same root, fourth root of all of them. So have a look. So if I were to break it up, it will look like this: fourth root of everything, like that. Here it is. Let's see. Okay. You don't have
Okay.
to. You don't have to. You can imagine it. But if you're not sure, you may want to write it. So here it is. So I broke them all into, split all the roots. Uh, yeah, split this big root into separate roots, fourth roots, all of it. And then watch individually. Follow the rule. Imagine you doing this individually, but going back this way, okay? So that means the first one, okay, the first one will be uh, x to the third divided by 4, like 3 over 4. Do you agree? X,
Mm-hmm.
the first one here would be, I'll write it below, okay. But anyway, you already have written, here it is, 3 over 4. And the second one, here it is. Now, if you don't see a 1, there's a 1 right there, always. Okay?
Okay.
So therefore, you write 1 over 4. But based on this rule, don't forget yeah, the denominator is always the root number. The denominator of the fraction is always the root number. Okay. Now this
Mm-hmm.
one, the last one, you didn't show the work that it turned into a half, but here it's supposed to be written like this
Like
first.
2/4, I'm
Yep,
betting.
2 over 4. Yep,
Yeah. Okay.
before you get here. There it is. And then you can reduce
Okay.
that and you get all this as your final answer.
Okay.
There you go.
That makes sense.
Yeah. Don't forget, you can always expand them. Like just break them up. Break them up if you need to. If you have hard time eyeing it, then break them up, write them out, and then
Mm-hmm.
use the exponential property here or the rule, one by one, and you just write them out. If you gain a fraction that's reducible, then reduce it. That's it.
Okay.
Okay, now a little bit. How about let's take a look at these ones. His work. Actually, it looks like one of your there's many of your problems are in here too. Like number one, you
Mhm.
notice? Yeah. Now let's look over here. Okay, yeah. So what I've done with him, now ignore the absolute value because you're not doing it. Notice what I've done here. I did the same thing. You know how you were saying, hey, should you not bring the number out? See,
Mhm.
normally if you have variables like m, n, a, b, whatever behind it, I would not do that yet until I reorganize them first. Then I would extract them at the same time. You see it? So the
Okay.
4 here,
So,
it's a 2, 2. See
well,
the
because
4
yeah,
is
you
a
can
2,
do
2.
4 and 11, and that's 2, 2, so you can take 1, 2 out.
Yep.
And
And
then
then
for the
this
m,
one,
because it's
1m,
3, you can
and
take
then
1m out,
that's it, 1n.
and
That's it.
then
And
1
then
m. Okay.
that's gone too, sorry. Then that's why 11m is left inside. There it is.
Hmm.
Now let's see
That makes
something
sense.
more.
I love that.
Good, good, good. Let's see something more fancy here. This one is not fancy, but it's the same thing as the last one. The 6 already exists on the outside. 72. I didn't prime factorize that because I know that a 9 times 6 and 9 is a perfect square. Now, perfect square, why? Because this is a square root. So yeah, so I left it as a 9 and 6, and the 9 will come out as a 3 because it's 3 squared. Is that okay? So here it is. And then this will come out as 1x on the outside. Why is this? My ink is kind of bold, thick. So there it is. I took out the 3 from the 9,
Okay.
and then the x squared comes out right here. There it is. The only thing you got left is the root 6, the 6 inside the root.
Okay.
And
This
then
doesn't
this
seem
is
too
18.
difficult. It
Nope,
seems pretty straightforward. I just
nope.
need to like think about everything.
Yeah. Now here, if you forget, like you don't remember, I don't like this one as an example. I don't know like perfect square in 48 except 4, but I still broke them up. Here it is. 48 is I did 4 times 12, and then I kept the 4. I kept the 4. That's gone. When I bring it down, don't keep it in. Don't continue copying it in the root. Let me think. No, I'm wrong. Never mind. I know what I'm thinking there. So okay. Let me do it different. 48. It's a
48
4 times 12.
times
Okay,
12 is 4 and 3.
and then 4 and 3.
Or
Yes,
that's
yes. Let's do 4
6.
and 3. Okay, then maybe we could just pull out the 4. So I see. I see. This is how
Okay.
my thought was. So I pull out 4 right here. Here it is, the 4, and then I kept the
Okay.
3 in there, right there. Is that okay? Yes.
Yep.
Try to organize it the best you can. But what I
And
did here,
then
though,
you can take
yeah,
an A out, and two B's
yes.
out,
You see that?
and
Yeah.
then one C, and then
But notice for
smush it all
48,
together.
that's it. I did not actually extract 48, the number part, until I organized the rest of them. So I kept 48 as a 4 squared times
Oh,
3.
okay.
See that? 4 squared times 3. This is
Yeah.
square. Yeah, that's 4 squared times 3. That's how I do it. You don't have to if you actually feel like you need to
Okay.
pull out the number, pull it out. But don't forget it. Don't forget that you already
Okay.
did. You can do it. You can do it any way you want. Your teacher will be fine, for sure. And here it is again, an odd root of a negative. Pull out the answer. The answer got to be negative. So I made an emphasis. Hey, the answer better be negative from all the way through, right there to the end. And then just organize the math. Do the math that you know how to do. 96. I don't know, so I broke them all up right here. It turned into 2 to the 5th, and the only thing that's not repeating is 3. So that's why I wrote 2 to the 5th and 3. An extra third. It's just divisible by 3. 3 divided by 3. That's it. So, but what's so unique about this one is that you have a lot left inside. Oh, I still broke up the 5. Oh, yeah. Oh, yeah, here it is. The 5 is still not divisible by 3. So I broke it up into 2 to the third and 2 to the second power. Do you see that? Right here.
Hmm.
And then I kept that back there. Once I get a number that is divisible by the index number 3, the smallest, the biggest one from 5, hey, not 4, 3. So and then the remaining 2 here. That's it. Organize to keep your work neat. It's the same. Yeah, right.
It's actually second, but just
Yep.
different numbers.
Now you know why those bands problems. Yeah, this is all I've got.
Yeah.
I think I'm
So
gonna
my
work.
teacher like a new one every day, and we have to like create a whole bunch of different things for every
Mm-mm,
single day.
I
And
see.
like apparently like the honors and AP classes do like 5 lessons every day according to my
I see.
friends, and I'm
I
like,
see. I
what?
see.
Oh my god.
Oh, I see. You got the honor counterpart too.
Yeah.
Yeah. Oh, yeah. So yeah, I hope you're gonna be okay here. This is the original what they look like here. I'm glad we went over because you got the operation of the roots and rationalizing it. Okay, rationalizing has to do with the is this problem. Where is that? Where do we do that? It has to do with you clean up. Here it is. This is rationalizing. Okay. You ever wonder what the instruction is going to be asking? It'll be asking right here for a fraction that has a root and denominator. That's when you rationalize. Now, obviously, you rationalize non-fraction. Normally, they would write simplify. You can simplify or evaluate. Function normally combining like terms add and then use fraction you write like a two version. So keep in mind you got into a root and a root convert back into a fraction. So those they'll tell you right using fraction exponent write in simplest radical form. So we got those. Okay. Oh, and solve. Okay. All right. Hey I have a feeling this is a quiz one. Here, let me give it to you quickly. Okay. Don't forget to be on your quiz. But I think it might be this one, the cube root one. Okay. Go at it this way. But this one that is like in there. Have a look. So make this up. I'll do a plus 2. It doesn't matter. Plus 2 and plus 5. Check this out. So this is just an example. This may be a test one. This plus 5 is on the outside. So you have to isolate this. All right, let's do it. Subtract both sides by 5. Now, this could come from something more elaborate than just this simple one. And then you get this right here. Now, tell me something about this step here. What do you think about it? What's happening here? Do you remember?
There.
This is a special occasion,
Oh,
a
we
special
have
situation.
to square
Okay,
everything.
I'll tell you. So yeah, I haven't actually shown you this. I only did it once. If you ever see a root equals a negative number, you stop
Oh,
immediately.
it
It
can't
cannot be.
because it
Don't
can't
try.
equal. Yeah, yeah,
This
yeah,
is
yeah, yeah, yeah.
okay. If you continue, if you were to continue, you won't get an answer or two answers, but this one you get one answer. What would happen is that this answer that you got, if you continue, if you check it and you plug it back in the original, it will not work. Here it is. This is the one. You know how you said your teacher mentioned, hey, you either gonna be the
Yeah.
answer will be two, one, or none. This is the none one. Have a look. I want to do it.
Okay.
Square both sides. Here we go. Square both sides. So don't forget, this is the original. Okay, this is the original. I made up. So I square both sides. I get x plus 2 equals 25, right? X
Mhm.
negative 5 times negative 5 is positive 25. Okay, subtract both sides. Here we go. Subtract both sides. So I get x equals 23. All right. So you think this is the answer. Some of you guys will keep it. It would be wrong. If this were a test
It
problem,
would be wrong
it would
because
be
if you
wrong.
check it, it
Here we
wouldn't
go.
fit in.
Yep, watch. I'll plug it back in here. Take a look. All right. Carefully, okay? 23 plus 2, that's a 25. A root 25 plus 5, is that 0?
No, it's
No,
not
no.
zero.
It's 5 plus 5. The answer is 10. So it's not equal to 0. That's why this is not true. There it is. So be ready. This is one that proves to you why you have to check your answer. Because I squared both sides right here. Now, I don't know this is going to be on the test. I'm sorry, I don't know this is going to be on the quiz. It's highly likely going to be on the test. This one for sure. What I was
Okay.
saying about the other one, about it being the test. So I would take this one over the one that I did with the root, the third root here. What was that? I rationalized the third root, remember?
Hmm.
Yeah, on the quiz, this would be more like it. On the test, for sure. But there was this one, I think, this one. Yeah, you're not likely going to get it on the quiz, but it's possible. A cube root denominator, it's possible. On the test, it's also possible. More like it on the test. But yeah, but this one for sure. On the test or on the quiz. This one right here. Anyway, all right. Carmen, good luck, okay?
Okay. I'm
Yeah,
gonna keep studying. I'm not gonna
yes,
stop.
yes, of course. Keep studying. Keep studying. Tell mom. I'll text mom to. I'd like to see Henry for Thursday. Okay. All right. Good luck. Good luck, Carmen.
Thank
carry on, study. Yeah, for
you.
Thursday.
Going to.
All right. Now, if you do have something new, you can tell mom you can take Henry's place on Thursday. But I'm gonna
I'm
assume,
probably not gonna
yeah,
get
I'm gonna assume
something
not.
new.
Yeah, I'm gonna
Just
assume not. So, all right. Take care, okay,
okay.
Carmen. Thanks for your
Bye.
attention.
Thank you so much.
You're welcome. Bye.